Thank you, Professor Bade, for the wonderful intro. I'm honored to be speaking here. So yeah, I'm Shia, and I'm currently my company is, as Professor Bade said, is helping enterprises adopt AI in a secure fashion, right? So today I want to kind of give a talk, more relevant to the audience here and somewhat relevant to what I'm building as well, which I will kind of show you a glimpse of it towards the end of it. But for most part, I spoke with Professor Bade and he said most of you are, data scientists, engineers, and somebody who's looking to build with AI. So I thought that, the content here could be very beneficial for you guys. Right. So all right, so let me see. So the AI actually has evolved so quickly, right? I remember 2 years ago, when ChatGPT first came out, it more than 2 years ago, it was mostly about, you know, more like traditional AI, right? Where it's a chatbot, right? You ask a question, and then ChatGPT will respond, right? So it's very human controlled, and the scope of what ChatGPT was able to do, back in 2023 was more limited, right? But as very quickly people realize that these LLMs are, they can think like a human, they can act like a human. So now, the Gen AI word, we don't hear it anymore. Now everybody is talking about agentic AI. So what is really agentic AI, right? It's really, you take LLM, you can program it to do things, right? So instead of just, giving ask a question and waiting for a response to come back, now it can do things for us, right? So here is an example of what is agentic AI in action. A very simple example, okay? A user like me, we can just say like, hey, please go ahead and schedule a 30-minute meeting with Sarah, right? So the agent would take this instruction. It'll first try to figure out, okay, what is this instruction about, right? Okay. Then they interpret the request and then they identify that, okay, I'm supposed to contact Sarah, right? And then this is about scheduling a meeting. So it also needs to find, optimal available time slots across different calendars, right? And then the wonderful part of agentic AI is it does these planning and then it can automatically execute for us, right? It can create and then compose a nice meeting invitation and then just send it out on our behalf, right? So the thing about agentic AI here is it thinks and acts like a human, right? And what's great about it is it can really streamline my tasks, right? So I can, make it even more sophisticated now, right? I can say, hey, every morning, please, do this at 8 a.m., go through all my contacts, right? Start scheduling meetings with them. So it's a huge time saver for all of us, right? So kind of this slides just kind of summarizes all the gains and, and the professional and the potential risk that will also come with it, actually. The gains, as I was talking about, right? Now this agent, like unlike me, who only has the bandwidth to process, to schedule a few meetings a day. After that, I'm tired. I need to get my coffee, right? I lose my focus. The AI agent is going to operate 24/7 around the clock. It doesn't need to take coffee. It doesn't need to go to bed, right? And it's really, able to do things, automate tasks at a scale that has never seen before, right? However, people also very quickly realize it, especially in the enterprise world. The AI adoption is actually not very high. Why? It's because people are afraid, right? We are afraid. If the agent has so much power, has so much privilege to do things for us, how do we control it, right? Will it do things that's unexpected, right? What can go wrong, basically, right? It turns out that, quite a bit can go wrong, right? So, for example, the same example, okay? Let's say, let's try to schedule a meeting with Sarah. Now this Sarah could be my colleague, but she's also my friend, let's say, right? Now, does the AI have enough intelligence to realize that this should be a business meeting, right? So, what if the AI accidentally posts her personal email instead of her company email, right? And now, as the AI is trying to compose a nice meeting invitation, right? What if it includes sensitive information, about company IP in that email, and then send it to Sarah's personal email instead of her company ones? That would be a big, data leakage concern for enterprises. And then last but not least, does the AI have enough judgment to realize that it should not be, CCing anyone else, right? If the email, the meeting invite contains sensitive information and the email gets distributed to a broader audience than what I had intended, then this could be a severe policy violation, right? So this is why, in production, we don't actually see in enterprises at least, right, AI doing that much work, right? It has a lot of capability, but it's not doing everything that it's capable of doing for us yet, right? So the example you can say that, okay, Dr. Hua, maybe you came up with it, right? But but the reality is, it actually the few cases where people try to roll out AI, there are a few cases where it did lead to some kind of fiasco. Okay. By the way, this is all in the news. You can kind of pull it up and read about it. Um, so, for example, McDonald's AI hiring chatbot, right? A hacker literally came with a password code 12345 6. Okay. And then the AI chatbot was, unguarded and ended up exposing millions of applicant data to the hacker, right? By the way, this image is also generated by AI. And then if you notice, there's a typo here, right? And then Replit, it's a very popular AI coding company. Okay. It ended up actually deleting an entire company's database, right? So this is causing severe outage for that company, right? So now, does that mean that we should not be using AI? I don't think so, right? It's if you look at the history, right, when internet first came out, people were also not sure, right? Like, what is it gonna do, right? And of course, hackers took advantage, right? But eventually, and we as humans, we are able to always embrace the new technology and put together the guardrails to help us kind of adopt it slowly, gradually, but definitively, right? So then people may be wondering, like, so okay, we have so many security measures. Why are they like not working, like, right, in this agentic world? Well, it turns out that, this agentic thing is so new that, the traditional security measures are just totally unprepared for it, right? Um, for example, traditional security typically defines on predefined rules, right? So as I was mentioning, when internet first came out, people don't know what to do with it, right? Like there could be, malicious websites, people sending requests to and stuff. And then people very quickly realize, okay, I can define rules, right? Like instead of, accepting anything, I want to impose HTTPS, right? TLS 1.2, TLS 1.3. So then there are rules you can use to safeguard malicious websites, right? Now, but in the agent world, it's very hard, right? Because agents are very dynamic, are non-determinist. If I ask the agent to schedule a meeting with Sarah twice, it might be doing different things, right? Because LLMs are probabilistic by nature. The second thing is, right, really the agents are so autonomous, right? They tend to operate within the system. And traditional security mechanisms are really good at defending the boundaries, right? So in the HTTP attack case, You just need to put, guardrails, security rules around your network perimeter, right? Then attackers cannot get through. But AI agents, once you give it the permission to do things on behalf of us, it's really gonna go just autonomously on its own and really go in very deep in the system, right? And yes, so the last bullet point just kind of emphasize that, right? So the traditional models is usually assumes, okay, human come define the rules and they will intervene when something goes wrong. But in the agent world, they act so fast, um, they make autonomous decisions. No humans can really catch up with that speed of operation, right? So what this really means is, as we all build agentic software, right? We all need to eventually build a new security system around it, right? And so this new security system should have certain capabilities, basically, right? By the way, this is so new that I cannot, it's an unsolved problem. So towards the end, I will point you guys to some research from Meta and Google, what people are trying to build around it. But this is so new, but roughly people know we can kind of envision, what kind of AI defense stack is needed, right? So first and foremost, the agent need to have some level of security awareness, right? Um, in the example I earlier give, I, me as a human, we understand that, okay, I want to schedule a business meeting, so I need to use Sarah's company address, right? So agents should be designed in a way to have some intrinsic security understanding as well, right? So then they can evaluate the risks before execution, right? Now, secondly, the guardrails need to be put around, right? So the security measures such as, don't put sensitive data in your meeting invite, etc. These guardrails can be built in to enhance agents' reasoning, right? So that the agent always performs a double checking, a check step, right? Before it performs actions, right? And then last but not least, right, the detection and response mechanism need to be able to handle the amount of operations that the agentic AI is producing because they move much faster. So the tracing they left behind is going to be a huge amount at a scale that we have not seen before, right? And then a lot of these actions are basically it's a chain of thought, right? It's not just one single action because the agent is going to take one action, evaluate, and then do the next one. So we have to have a new kind of monitoring and analytic ability to analyze the train of thoughts. Right? So so for example, coming again back to the first example, if you are building this agent, and you're trying to roll this agent out in production, what are the guardrails, practical ones you can really build in, right? So the agent, again, it'll still, the first step is the same, right? It'll understand and plan it out what needs to be done, right? But before it does the scheduling, right, it need to evaluate, right? Evaluate the meeting invitation against the guardrails and the security policies, right? Ideally, also log the intent before taking actions. In case something goes wrong later, then we can come back and have some forensics evidence, right? And then even more importantly, for high risk activities, it should have the awareness for user approval. Yeah. Now, for the most part, it should be autonomous because otherwise, I don't think any way human can catch up. But for really high sensitive operations, human in the loop is also important, right? Wait for user consent, you know, before sending a very important email. So, for example, if Sarah is um, a very important person, at the company, then, and the meeting does have, some important implications, then wait for user approval, right? And here's an example of the kind of the policy guardrail that you can put, right, in your agent. For example, you can say, hey, please don't use, when you send the prompt, right, you can even put this in saying, don't use personal email and don't put in any sensitive data, right? So yeah, now I want to mention, kind of go a little bit deeper on the more technical side, on the building blocks of these agentic actions, right? So in this example before, let me just go back one slide, right? Here, if you look at this chain of thought, right, the agent is taking, right? It's actually doing a lot of things, right? Interpret the request, identify participants. How does it identify a participant? It has to go to my contact list to pull that out, right? And then it has to find some optimal time slots. So it had to access my calendar, right? And then finally, it composes the email and sends the meeting invitation, right? Now it's accessing my email. So in this mm, one action, one task, it's at least touching my contact list, my calendar, and maybe even Sarah's calendar, and also definitely my email, right? So how is it able to do that, from a technical stand? What's really making it possible is this new protocol called MCP. I'm sure many of you have heard of it. If you have not, uh, this is a new protocol, relatively new protocol that that was introduced by Claude at the end of 2024 in November. So close to a year now, 10 months. So it was adopted like a wildfire, basically, right? So now, if you use Claude Desktop, you probably you can try it out like fairly easily. You can basically hook up your Claude to many, many, many different sources, right? Like the example I mentioned, you can hook it up to a calendar, can hook up to your email, and then Claude would literally just do the task that I described, for me. I tried it; it works, right? So I really like this. I pulled this from this website. So think of it as the USB hub of AI, right? Basically, you have very many different data sources where you can pull data and you can do things. This MCP protocol is where it's like a next generation of HTTP for the internet. It basically allows agent to be able to access these tools. So then it sounds all good, but being a security professional, I always have the tendency to see, what are the risks that come with it? Okay. So it turned out that MCPs are possibly the most unregulated and the most risky thing that the all of us have seen in a while. So here is an example of a pretty malicious MCP in action, right? Um, so this MCP can, secretly read, a secret file, a sensitive file, configuration file, on my laptop, and then it can extract my password and the sensitive environment variables, and then send them in it as part of the content in an email to an attacker. Okay. And then it's doing this, because of this prompt here, right? It's a smooth experience. It's not revealing this at all to me. So if my Claude decided to invoke this MCP, okay, and then my information, my personal password would just go, to this attacker. I tried it on my personal email, so it worked. So But imagine, if it's an attacker who could get hold of access to my to my Claude, then it could be doing that, right? So this is why, in MCP, this is also part of the reason why, MCP is a lot of the enterprise companies are trying it out, but we're not really you don't see it in production that much. Okay. Part of the reason is there's no clearly defined guardrails around it, right? So this really reminds me of the early days of the internet. It's exactly the same thing, okay? When something new comes out, right? There's plenty of curious people trying to kind of defeat it, trying to see, okay, what are the interesting things I can do with it, right? Um, so yeah. So with MCP, right, it definitely comes with its own set of kind of vulnerabilities because it's in really early days, right? Like the example I give on the previous slide, right? Um, so sensitive data leak, data exposure again, right? And now this play the M if an MCP server is malicious, right? It can really just kind of exfiltrate data, my personal data out, right? The previous example actually is a great one. It's doing pretty much it it exposed my personal data, and then there is context poisoning in that malicious MCP, right? Um, so if you're developing anything with the AI agent, I'm almost certainly sure you have to use MCP. Make sure that you really know what MCP server you are using, right? And this last thing is it's also pretty common, right? You may be thinking that okay, I might be using a GitHub MCP, but it could be a spoofed one, right? And it could be intercepting my call in the middle, right? In the HTTP world, we have to first do a handshake, TLS 1.2, TLS 1.3, to make sure, hey, you're really GitHub. In the MCP world, we don't have that protocol yet. Okay, so double check if you are using a remote MCP that's not developed by yourself. So yeah, so here's also some security framework that you can kind of I would I would call it practice you can follow until people have built more guardrails around MCPs, right? Always scan it, right, before using it, right? Making sure that it doesn't contain anything vulnerable in there, right? And then really the zero trust is a very important security principle, right? We always assume bridge and make sure you verify every request that goes out and then sanitize every request that comes back, right? Make sure you don't send out anything sensitive uh, when you're invoking an MCP server, basically, right? And least privilege, that is yet another very, very important security principle, right? So instead of giving MCP access to the entire file system in the example I was showing, right? You can block it off, right? Don't act making sure it does not access anything on at the root level, right? Don't use a root role to execute anything, right? Use you know assume a role at the user level, right? And then, always log basically, right? If something goes wrong, then we can go back and analyze, fix the problem, and then enhance and iterate. So yeah. So I know it sounds kind of all scary right now, but the world is all quickly moving towards trying to put some framework and guardrails around this whole thing, right? And I kind of want to share some pointers with you guys first. So then, if you're developing AI or you're using MCP, you have somewhere, you have, some tools available to you, right? First thing is this Llama firewall, right? Llama Firewall was, I think this paper was published very recently, right? So it's built by Meta, a great set of folks. So all basically it's trying to, it's open source, which is fantastic. It's a guardrail system for folks to secure AI agent, pretty much following the principle I mentioned before, right? It has three major components. There's a prompt guard. It can detect, any request that comes in that, potentially, a chain of requests that's trying to, break the system, right? And then it also offers agent alignment check, right? So basically, like I said, right, agent doesn't just do one step. Agent performs actions in multiple steps. So Llama Firewall allows you to go back in steps and then kind of analyze how the agent was thinking, right? And then the code, sorry, this is a typo here. The code shield. Code shield here is a sort of a standalone. It's primarily used in the case where if you are kind of using AI generated code, then people have actually found a lot of security issues, from thousands of lines of code generated by, the very popular coding assistant, right? I think there's a report somewhere that more than 85% of the code in the YC batch, Y Combinator, is generated by AI today, right? And I myself as well, I would say for me, it's 90%. Me and my co-founders, we, use a lot of Cursor, we use Clock Code and stuff. So yeah, so this is very helpful as well. Um, and then there's also a very interesting paper, also published very recently by Google DeepMind. Um, this is a kind of practical, very practical use case. How Camel would process a user query, right? So basically, it's more or less kind of putting whatever I described before in a more executable fashion, right? Um, so so basically here is all about execution, right? You would find Bob's email. The task is to find Bob's email and then send him a reminder, right? So one LLM will be kind of generating the code, right? Okay, find Bob's email and then okay, now let's send email, right? And then your camel would be kind of maintaining, a dependency, right? Like which action depends on which action, right? And then it also understands security policies, right? For example, send email if only if recipient is trusted, and get the last email always allowed, right? So basically, it kind of teaches you, it's an example of how to actually put it in action, basically using policies and then build a, dependency graph using that to kind of um, to guard around the code execution. Yeah, so this is very interesting to me actually. Last but not least, I kind of want to just quickly show you guys what industry tools like Traceforce can help you guys as well. Let me try to see. Um, so here is a window of you guys can see, right? So we are more enterprise security company to help enterprises kind of um, manage the AI usage across organizations. So if you ever wonder, oh, I got a new MCP that I want to roll out, for my company to use, you probably don't want to do the work of going through all of these to figure out, is this a you don't want to, you want somebody else to basically scan the MCP and tell you if it's good or bad, and that's what we do. So we curate hundreds of MCPs out there. So for example, GitHub MCP, right? We kind of we are able to hold on, sorry, let me see. So we are able to kind of, establish a baseline. What are the average risks of users using, GitHub MCP, right? And then we can help folks basically follow the best practice. So for example, in the GitHub MCP example, we can help you in the GitHub MCP can be running in a container. It can be running in as a remote server as well, right? So we can help you or even unrestrictedly local, right? So basically we can help you enforce it in a way that it's most secure. Like in this case, we can help everybody move the MCP into a container, right? And yeah, we can help you do version control and these kind of things. Yeah. So everything is based on these framework, right? And yeah, and so if you're personally, want to use a certain agent, for example, Cursor, one of the most popular ones, right? We can also give you some guardrails, some recommendation, of where the things that you need to pay attention to, right? For example, make sure that you use OAuth, don't give a password, right? And Cursor has a training data usage toggle, right? Make sure if you don't want if you're using Cursor to for use cases like with touches medical data or whatever, right? You may want to be able to make sure that you turn off the shared mode, but making sure your data is not used for training, etc. Right? Um, yeah. So this is a kind of a very high level overview of what Traceforce does, right? We build these frameworks, we enforce it across um, many users in a company, basically, right? And if you are just a student or you're a data scientist, then I think I can just share these framework for you for if you need to evaluate whether you can use an MCP or an agent, plug it into your system. Uh, cool. Yeah, this is pretty much all I have. Let me just do a quick recap here. Coming back here. Um, yeah, so takeaway here. Sorry, I'm not able to do a full screen here, but that's okay. Um, So yeah, just a quick recap. I think we walked through some of the risks that agentic AI, the new risks the agentic AI introduces, and kind of try to get an understanding why traditional security models are insufficient, right? And then we looked a little deeper into the building blocks of agentic AI, which is really the MCP, right? And yeah, for MCPs, we need to establish a new baseline of risks, right? And then try to put remediation strategies around those, right? Yeah, and then lastly, right, I share some pointers, tools out there that can help you guys, implement these controls before you actually deploy them in production. Cool. All right, any questions?
Yeah, if you have any questions, you can ask in Q&A. There's in Q&A actual questions there. Did you see the question from Q&A.
Let me see. How do I see?
So there is a Q&A in the bottom panel.
Okay. Yeah.
Okay.
Mm. Question, how did we define the risk scores? Many risks we supported in the prod? Thanks. Okay. This is a question from Yan Hui. Thanks a lot. Should I unmute Yan Hui? Uh, or uh, answer live? Okay. Let me just quickly go back to uh, sorry, I'm not very good with this meeting system. Yan Hui, thank you for your question. I think you are, is it, is it possible for me to unmute a certain speaker?
You can actually go their names and ask them allowed to talk
Oh, okay.
if you didn't understand the question,
Yeah,
if they want to ask the questions. Yeah.
okay. Yeah, so I just want to double check that uh, Yan Hui, I think I unmuted you. I just want to confirm with you that uh, this is what you're referring to. Is that right?
Yeah, hi, so Dr. Xia.
Hey, yes.
Okay, yeah, nice to meet you.
Yeah.
Yeah, actually, yeah, just yeah, for your production. So, yeah, I just want to see, okay, like how many
Mm-hmm.
like risk you defend already, and how you just define the risk and the score, and give the some the different level or severity.
Mm-hmm.
That's the first question, and I think the second question, like you mentioned in the presentation, like the AI security is totally different with the traditional security. Like
Mm-hmm.
we can't like define some rule to detect it, right? But
Mm-hmm.
if the some like MCP, like some MCP server,
Mm-hmm.
if there is some like a malicious, either like a code execution or something in the instruction, so
Mm-hmm.
it will cause some compromise. So
Mm-hmm.
for this kind of attack, like how your system can detect and prevent this kind of
Uh,
attack.
okay, got it. Okay. So for your first question, you were asking how we define these scores, right?
Yeah.
So this is pretty much so me and my co-founder is a VP of Security Operations previously at Sky High, and we also work together at a data protection company. So basically, we talk to our design partners and we curated this list with some help from LLM as well in full transparency. So a lot of this follows the Sky High and the Netscope CASB model sort of. So we knew that there are these categories that people are looking for. And then what we do differently is we really, for each of the categories, like access control, we really want to drill deep and understand what is special for the AI use case. So for example, for data governance, we really go into every detail to see what are the toggles that security controls we want to offer people.
Okay. And the score, what this means score here, like a 10, 40,
Yeah.
80.
So that's a great feedback, actually. I think I should do a better job in our UI. So So a lot of these scores are more, so let me maybe training data, lower
Mhm.
meaning less risk, higher meaning riskier. Okay. So if let's say in an example of a cursor, um, so if your instance you on a particular device on a laptop you have not enabled privacy mode, then your data will be shared. Then we would give it a risk score of 90. If you have enabled privacy mode, then we will give it a risk score of 10. So remember, lower is better, lower is green, higher is worse. Okay. In full transparency, we did get feedback on people. It's like, why is it 40, not 45, 43, right? We take
Mhm.
these feedbacks and maybe we're thinking about moving more to a scale of like 1 to 10, right? But overall, we want to give people a more quantitative understanding of the risk level, right? Is it
Mhm.
very high risk or is it low risk?
Gotcha. Yeah. Yeah, thank you. And the second question, any like a mechanism we can detect or just prevent some your attack, like a code execution from the MCP server,
Yeah.
in some like a malicious instruction or something.
So yeah, so that you would really need some kind of MCP scanner. So it's something that we have at we built at Traceforce. So we basically part of what our product does is we actually go around and scan every device in your if you're a company, okay? And then we will find out what are the MCPs in use, and then we can identify all the top issues. So, so we really scan, all the MCPs, the configurations. If it's a local MCP, then we scan the file.
But
So
how,
in the
yeah, sorry to interrupt you. How we can just deploy your product in my enterprise? Is a like a gateway or is a like
that's a great question. We are a package, a binary that's deployed via MDM, uh,
okay.
a GEM, mobile device management service. Yeah.
Okay, I see. So you just try to scan and
We
based on
scan.
the response, so
Yes. Yeah.
we just determine okay it's malicious or not.
Yes.
So
Yeah.
are we using some AI like a model to detect it's malicious or be not?
That's a very good question. The ultimate answer is yes. Okay. But currently, because the scam primarily run on your device, and most devices cannot support very large models, so we don't use large models. We only use a simple ML rules to detect. So in
Okay,
the future, we will offload some of that for LLM to process, but that LLM has to be hosted within your environment because of data protection reasons.
gotcha.
Yeah.
Okay, good
For
to
now,
know.
to
Yeah,
reduce friction, that's why we have a more basic ML rules, just simple ML classification. Yeah.
I see. Yeah, thank you so much. Yeah, for your answers and yeah, great presentation. Yeah, cool.
All right. Yeah. Thank you. I think there's a second question as well.
There's two more questions there.
Okay. Q&A. Can you elaborate how I can use this tool as Odell? Okay, let me see the users. I need a clarification again on which tool it is. Um, I think
Yeah.
hi, Odell. Hey,
Hi. Yeah. Can you hear me?
yes, yeah.
Okay. Okay. Thank you. Thank you for this excellent presentation. You know, with what you just explained with the previous person, I understood that if I am, in my company, I develop a lot of tools using AI and, or MCP protocols. Um, I can use your tool to scan the whole thing, and your tool will tell me which one is protected or vulnerable or whatever. Is that right? Is it the right understanding?
Um, the answer, I think at the high level, yes, yes. We can
Okay,
also scan individual MCPs.
okay.
Yes.
But my question actually before that is, if I'm developing something, I have an application, I'm developing the whole application with the protocol, the MCP. How can I integrate your tool in my development process to make sure that my final product is protected, or is secured?
So let me try to repeat your question. So you are developing an agent
Yeah.
using MCP protocol, right?
Hmm. Hmm.
And you want to know how our tool can be used to help you make sure that the final product itself is secure, basically, right?
It is, yes, it is correct.
Yeah. So can I ask you a question? So how does so the development is probably first done on your laptop, right? And then
Yes.
how do you what does your CI/CD pipeline look like? How do you push it to production?
honestly, I'm not a professional developer, so that is a bit higher level for me. At this now, I'm saying, because I'm not doing that in a big organization. I'm doing that at the,
Mm.
how can I say? Yeah, yeah. So now, if you tell me that where I can use the tool is when I will be ready to push my development through the process you just mentioned, I can understand that I still need some time for that.
Yeah, so I think our tool, the scanning part works should also be helpful for you because when you're in your development phase, right? Basically, all you need is deploy our scanner either on your laptop or in your CI/CD pipeline, right? It has to
Okay.
run somewhere, right?
On my laptop, let's go with my laptop because
Yeah,
that's
on
where I
laptop
am
is
doing
probably
it. Yeah.
easiest, right? Then
Mm-hmm.
we will go around and find out all the MCPs, the MCP.JSONs, right? As long as you
Okay.
follow certain convention, we'll find all of them. And we can also find, which agent is trying to call that MCP. So
Okay.
we,
But then what, because imagine that you find some weakness in what I'm doing. I am having a big security issues. So are you also suggesting the solution to fix it?
yes, yes, that's the key part.
Okay. Yeah.
Yes, yeah,
Okay.
yes.
So your tool, is it something that somebody can buy, or you will be always there working with the organization?
So we do have a single user mode as well to download the binary and to scan. But primary use case currently is for enterprises to deploy at a scale. However, we can deploy onto a single laptop for sure.
Okay. Thank you. Thank you for that.
Yeah. Thank you. Thank you for the question. Yeah.
You're welcome.
Thank you for. I wonder the next question is from Ibram. Maybe I will just mute him quickly. Um, Hi, hi, Ibram. I think I unmuted you. Thank you for the question. Yeah.
Thank you. I just wonder, yeah, if you have any knowledge of how practical and agentic AI could be used for this purpose as well for research, just running experiments and doing the things when we're tired and asleep and carry on the research. How practical is that? And do you have any do you have do you know of any organizations running this kind of agentic AI for this purpose?
So I think MIT recently published a research that 95% of the enterprise Gen AI use case has seen no return. So I think the reality here is um, where AI sees most adoption, I think is coding assistant, right? Like cursors, I personally use Cursor, Lovable. These have literally caught, they work so well, right? So to answer your question, I have not seen a practical use case where anybody is able to run an AI for at the quality that research scientists would would feel comfortable, right? So I think it has to do with the biggest challenge here is really the training data set preparation. It's with all things AI, whether it's Gen AI, Agentic AI, or ML, it's junk data in, junk result out. Whatever data you feed is the most important. So I think that's where most enterprises and business struggle, right? They probably have some use case, but they are not able to prepare the data set enough to train their AI models on. I don't
Yeah,
know if
but
I'm answering your question.
yeah, I understand, and the only the practical thing I'm seeing is that you could have imagine that for if I'm on holiday for a week or something, I could it would be nice to come back and see that during that week, the the agent has managed to continue some of the result, some of the work, and came up with some interesting outcomes while I'm away for a week.
That's very interesting. Yeah. I think the challenge with agent is it's probabilistic, right? So if it takes one step that deviates from its final goal, it tends to go on a path of no return. It's kind of just keep on deviating, keep on deviating. So for very long running experiments, um, unless you try to come up with the prompts that make it a more predictable, more deterministic, um, it's very possible, during that long weekend, it probably
Yeah.
deviated a lot from
Yeah,
what you had
I want to make sure
intended.
I would make sure that wouldn't use I would have a limited number of GPUs to use and
Yeah.
number of a limited number of experiments to run, and yeah, so adding constraints, which is the point that you mentioned earlier for the other sides of problem for with agents.
Yeah. Yes. Yeah.
Thank you.
Thank you. Thank you for the question. Yeah.
By the way, so can you please share like how to pronounce your name? So I joined late. Sorry. Yeah.
Yeah. My name is Xia. Xia. Yeah.
Uh, Xia. Dr. Xia. Is
Yeah.
it Xia or Xia?
Hua is my last name.
Oh,
My
Hua.
first name.
Hua Xia. Okay, gotcha.
Yeah.
Yeah. What? May I ask one more question?
Uh, sure.
Do
I
we
think
still
it
have
should be
time?
okay, right, Miss Pade? Do we still have time?
Yeah, we can have the last question. Yeah.
Okay. Yeah.
Okay. Cool. Thank you. Actually, so like for my use case, like I have like a agentic AI, so I deploy in my lab, and then so everyone just use this agentic AI to like search some like threat intelligence and answer any question like analyze some file pickup data.
Mhm.
So and also this agentic AI also called a different MCP server
Mhm.
and the different tools, right? So if I want to use your product, I need install this the package on this server, right? And then it can scan this server to see how many remote MCP server and the local MCP server. So there is some risk or not. Is that correct?
Yes, yes, yeah. Whatever machine you want me to discover it on, yes. But there may be different models we can discuss. For example, if your code is hosted in GitHub, then we can directly scan GitHub and tell you, right?
Okay, I
All
see.
we need to get hold of is that mcp.json file.
Okay, I see. Gotcha. Okay. Thank you, Dr. Xia. Yeah.
Make sense?
Yeah.
Yeah. Basically, we can scan your code base as well. We don't have to necessarily be live on that machine.
Okay, I see. Gotcha. Cool. Thank you.
Yeah, by the way, I think my email is also available, right? If you have any other questions, feel free to email me as well, right? Is it okay if I share my email?
Yes, yes,
Yeah.
please.
Yeah.
So thank you, Dr. Xia, presenting. I think it's got quite interest from people. I think it's really important. A lot of people don't know about the importance of that. And then we will have another one. I think as people more building agents, they need that a lot. So thank you everyone for participating as a midday in California. I know some in some countries is very evening and night. Thank you for great participation. So
Yeah. Thank you so much. Yeah, thank you. Yeah.
to see you next event.
You
Bye.
enjoy the talk. Yeah, thank you. Yeah. Bye-bye.
Thank you.
Thanks.
Bye.
Thank you.